Okay, welcome back to the part 2 of the video. And you can see I've done a small change. Due to 3 boxes just to represent our separate VLANs. And now let's dive into the configuration. So as you can see, we have 3 layers as usually in networks. This is the access layer. And we have our distribution layer. And then we have our core layer. So we'll start configuring from the access layer. Then we can move up to the core. That means the core layer. Right. So let's move to our switch one. So the first thing first, we have to make our VLANs. So let's make our VLANs first. So enable. First of all, I would like to give a name. So I'm going to give the name host name for my switch. It's going to be VLAN and switch. So it's going to be V10S. So I'm using the names given in that table. In the last video, I showed you guys this table, right? And this table. So I'll be using the same names here. So next one is going to be enable conf t host name is going to be T20 switch. And then for the last access layers, which is going to be enable conf t host name is going to be V30 switch, right? Now let's start creating the VLANs because we have 3 separate VLANs in the 3 separate switches. Okay, so it's going to be very easy. We are going to first select our interfaces. So we have 2 interfaces within this VLAN. So I'm going to say interface range FA0/3 to 4. And then I'm going to say this is going to be a switch port mode. Either it should be access or trunk. Since we are only accessing single VLAN, this is going to be access. And I'm going to say switch port access VLAN N. I think I did a small syntax error. Right. Now you can see you get a small feedback. This is not a warning, just saying access VLAN does not exist. So because of that, we created the VLAN 10. That's fine. I'm going to do the same thing to here. So I'm going to say interface range FA0/3 to 4. Switch port mode access, switch port access. Now it's access VLAN 20. Again, the same syntax error. Okay. I'll do it correctly in the next one. I have to make sure I'm typing correctly. So interface VLAN, sorry, interface range FA0/3 to 4. Switch port mode access, switch port access VLAN 30, right? So now we have created our 3 VLANs. If you want to double check, you can simply execute the command show VLAN brief in all 3 switches, and you'll see in here VLAN 10, the 2 interfaces are active, and same story for here. So you exit, show VLAN brief, and you can see here we have VLAN 20 assigned to these 2 interfaces, 3 and 4. And again, same story to the other one. Let's try it as well. Might as well. I'm going to exit from here again, and I'm going to command show VLAN brief. And we have 30. Yes. So everything looks fine up to here. Now let's move to our distribution layer, right? So in the distribution layer, we have these 2 distribution switches. So let's give them names first. I'm going to say enable key host name. This is my multi-layer switch 1. So I'm going to say MS01. Press enter. Same story to this side. Going back here. Enable the host name MS02. Okay. Now we have to make sure all these links are. We have to make sure all these links are trunks, right? and other 3 as well. These 3. Okay. So let's make them dynamic desirable. Means they'll automatically form trunks with the other end. So I'm going to go here and I'm going to say interface range. As you can see, the range actually starts from 0, 2, and it ends from 4. See, you can see is 2, 3, 4. So I'll use it. Interface range FA0/2 to 4 in this case, right? And I'm going to say switch port mode dynamic desirable. I think, okay, it's a small syntax, okay. Switch port mode dynamic desirable. Press enter again, the same mistake. I type letter C wrong. Okay. Right. I didn't get any errors. So you can see it gives some sort of a output or a feedback saying these protocols, these interfaces went down and then again they came back up. Right. Then let's do the same thing to the other interfaces as well, other router as well. Sorry, the switch as well. So I'm going to exit from here. I'm going to do the same thing in this case, conf t, right? And interface range, FA0/, this is starting from 2 to 4, same as before. And I'll be saying switch port mode dynamic desirable, right? Then I'm going to say switch port mode. That's it, right? Switch port mode dynamic desirable. And now, if you want to check whether the configuration is okay, you can go back and type show interfaces trunk. In this one, you can see these 3 are now trunk. You can see mode is desirable, desirable. So they are trunking. Status is trunking, right? So there's no problem there. And we can run the same command in the other side as well. Exit, and type the command show interfaces trunk. And same output as it is, 2, 3, and 4 in desirable mode, and it is trunk. Okay, we are good to go. So now we have done the trunking for the distribution layer. Now let's do some work in distribution layer. Let's create the SVIs on distribution layer because we have to make sure the SVIs are available for HSRP. So now I'm going back to here. And I'm going to first create my VLANs here as well. I have 3 VLANs. So I'm going to create my VLAN. So I'm going to go to the configuration mode. I'm going to say VLAN 10, exit from here. VLAN 20, exit from here. VLAN 30, exit from there. Right. I'm going to do the same thing in the other end as well. Go back to this side. CLI, conf t, VLAN 10, exit. VLAN 20, exit. VLAN 30, exit. Okay, so I've created VLANs. Now let's give IP addresses to each of these VLANs. So I'm going to say interface VLAN, right? Then I'll give IP address 192.168.10. So in this case, for the VLANs, I'll give, these are the VLAN IPs, okay? So for the VLAN, I'll give, for the VLAN 10, I'll give 10.1. For VLAN 20, I'll give 20.1. And for VLAN 30, I'll give 30.1 in the active side, in this side, okay? So I'll give 10.1. And the subnet mask is going to be 255.255.255.0. All right, I'm going to exit from there. So I can just say IP set interface VLAN 20. IP address is going to be 192.168.20.1, and the subnet mask is going to be this. And same story for VLAN 30 as well. So interface VLAN 30 IP address 92.168.30.1.255.5.255.0. Okay. So if you're doing this, follow along with me. So it's going to be easy for you as well. So since I mentioned those IPs, I'll like to write those IPs here. So for the VLAN 10, the IP address was, these are not virtual IPs, okay? Keep that in mind. These are the actual VLAN IPs. So then this is going to be VLAN 20, 192.168.20.1, and this is going to be VLAN 192.168.30.1. So I'll tell you what's happening here. If you actually use default gateway IP as here, so in here you can see the default gateway IP is 192.168.10.100, right? But if you make it 10.1, it will work because then it will go through this VLAN and it will go to this router. But if we tell it is 10.1, the problem is if this router or this switch goes down, then it will try to push the traffic to this side, but it is already down, so our packets will be dropped. So because of that, that's why we are using a virtual IP. So the virtual IP will be shared between the two layer 3 switches. So if this one goes down, these virtual IPs will be taken by the standby route, right? So VLANs will have their own actual physical IP address, like the actual IP address, but these are the virtual IP. So we are going to use HSRP to bind this IP address with this virtual IP address. That's the idea. So for the standby side, I need a virtual IP address as well. So I'm going to copy this entire thing and I'm going to paste a copy of that. So can I copy this? Yes. Not enter. Okay. I'll take a note, again, put it here. But in this one, this is going to be not 10.1. I can make it 10.2, right? This is going to be 10. Right. So this is for this one. Right. Now let's configure the other side as well. I already created the 3 VLANs. Now I'm going to give the IP addresses. So interface VLAN. Now the IP address is going to be IP address 192.168.10.2. In the other side, it was 10.1. In this side, it is going to be 10.2. And I'm going to have to give the subnet mask. Sorry. 0 and exit. Then interface VLAN 20 IP ADDR 192.168 20.2 255.255.255.0 and exit. Then interface VLAN 30 IP ADDR 192.168 30.2 255.255.255.0. Okay. Looks good. Now we are done with that part as well. Now let's check whether we have connectivity between our two SVIs. That means the connectivity between this L3 switch and this L3 switch between the VLANs, because if we want to configure HSRP, first we have to make sure we have the connectivity. So from MS02, that means from 192.168.10.2, I'm going to try to ping 192.168.10.1. That means this side, right? I'm going to press enter. Okay. Right. It gives me a success. I'll try to ping 20.1 as well. Yes, it is successful. And I'll give a ping to the other side as well. Hopefully it will be successful. Yes. So I'll be doing the same from this side just to make sure everything's fine. Ping from 10.1 to 10.2. So 10.2, yes, successful. 20.2, entirely successful. 30.2, successful, right? So now we have the connectivity between the two. Now let's move for HSR. So if I'm typing things a bit fast, you can slow down the video playback speed and you can follow along with me, right? Right. So let's configure HSRP in MS01 for the multi-layer switch 1. So I'll be going back to configure terminal, conf key. In here, I'll be moving back to my interface. Interface VLAN. Right. So in here, I'm going to give my standby priority. I'm going to change the default priority value 100 to 110. So I'm going to say standby 10 priority 110. Right. Then I'm going to say it's preempt standby 10 preempt. And then I'm going to give the standby IP, which is going to be my virtual IP. So standby IP 192.168 10.100. And I'm going to exit. Okay. And I'm going to do the same. So in, to the other VLANs as well. So interface VLAN 20, right? Standby 20 priority. I'll explain one more thing as well. So in this case, I'm making my standby router for all three VLANs going to be MS01. But if you want to make for VLAN 10 and 20, the standby router is going to be this one. Sorry, the standby layer 3 switch is going to be this one. And for VLAN 30, if you want to make the standby, sorry, not the standby, active switch should be this one, then you can actually change the value for the priority in here. I think you are not clear with what I said. So in this case, since I made the standby priority, right, 110, because of that, this switch will be the a switch for the VLAN 10, and I'll be doing that for the VLAN 20 as well. So you can see for VLAN 20, the standby priority, we change it to 110 for this switch. So the active switch will be this one. But if you do the same thing to this side without doing it here, then the active switch will be this one. So in the exam, I might ask you to make like this. For VLAN 10 and 20, active switch should be this one. For VLAN 30, the active switch should be this one. Then if that's the case, for VLAN 30, you have to execute this command, not in this side, you have to execute in the other side. That means in the MS02. I hope you get the idea, right? So I'll continue my work. So I executed the command standby 20 priority 110, right? And then I'll give standby preempt. And then I'm going to give standby. Right. So you can see while I was typing, I got an update from VLAN 10. State standby, I got the update. So it is now active as well. So for this one, I'll get the update as well eventually. So I'll explain what I did again. So I ran 3 commands here. First, I access my VLAN 10. Then I changed the priority value to 110. Default value is 100. I got the update for the second VLAN as well. That means for VLAN 20. And then I made it preempt and then gave the virtual IP. But if you want to make the other switch, the active switch, then you have to execute this command in the other side. And you have to skip this command in this side. Okay? So only you are going to type VLAN 20 and then standby 10 preempt, standby IP this. And in the other side, you are going to run this command. Okay. Okay. So let's configure the other interface as well. So exit from here. Interface VLAN 30. And then standby 30 priority is going to be 110. So in my case, active switches for all 3 LAN or all 3 VLANs is going to be my MS01. That's why I'm changing priority value 110. All 3 VLANs in this same switch. Then standby preempt. And then the IP address. Okay. So the configuration in this side is done for HSRP. Let's switch to the other side. In here, you will see the commands I'm going to write is going to be slightly different than the previous one. So I'm going to go to configure terminal. And here, same as before, interface, VLAN 10. But here we are not going to change the standby priority because the priority we change it in the other side to 110. So here the default value will be there. That means 100. So I'm not going to run that command. I'm simply writing standby preempt, standby 10 preempt actually. And then I'm going to give the IP. 192.168.10. So you get the point, right? If I change the preempt, if I run the command standby 10 priority 120, because in the other side it was 110, then this one will become the active router. But in this case, I don't want to do that. Because of that, I'll be doing the other configuration. So interface VLAN 20. You can see I got the update here. And then here I'll be running standby 20 preempt. And then the standby IP 192.168.20.100. And I'm going to exit from there. Right. And then interface VLAN 30. Interface VLAN 30. Right. And standby 30 preempt. Standby IP 192.168.30.100. Okay, so now everything is done for HSRP. You can run the command exit from here. Show standby. From here, you can see this is actually standby, right? And if you go to the other side and run the same command, show standby, and you can see this one state is active. In the previous one, it was standby, and this one is active. So you can take note on this one. So in the VLAN group 0, it is active. In the VLAN 20, switch is going to be the active one. And in the VLAN 30, this switch is going to be the active one. And in this side, you can see I ran the same command, but this one standby. In this case, it is standby. And for the VLAN 30, it's again standby as well. So it's still in the speak state. Now, if I run the command one more time, I'm pretty sure it's going to be the standby one. So you can see now it is standby. So now we have configured HSRP, and now you can actually try to ping from your computers to the virtual IPs, right? So this is my VLAN PC. From here, I'm going to try to ping to my virtual IP. So let's see whether it will work. Ping 192.168.10.100. Yes, I'm getting a reply. That means it's successful. So it will work to this side. I'll try to ping to this one. $20.100. Yes, I'm getting a reply. And I'll try to ping to 30.100. Right. So HSRP is nicely done. It's working. Now let's make it work to the other end. Right. Now let's configure the connection between the distribution layer and the core layer. Right. You can see this is our core and this is our distribution. Now we have to configure the routing between these two. So remember, this is no longer switching. Now we are moving to routing. But this is a layer 3 switch, right? So we have to enable routing in the layer 3 switch. So how can we do this? Very simple. You are going to run the command IP routing, right? You're going to run the command IP routing. So now I have to go to configure mode. So conf T, and in here I'm going to run IP routing. So now this is no longer a switch. Now it is a switch with routing capabilities. I'm going to run the other side as a conf T IP routing. Okay, now we are ready. So for this network, I'll use the IP. This is the network IP. It's going to be 100, 200, 100, 0. I'll use the /30 for this. If this is the 100 network, this interface will get the .1, right? The top interface will give it the that's 100, 200, 100.1, and the other one will be 100.2. So in the top, I'll make it 100. Like this. Better, no? Right? Same story. Let's use this side as how about a very similar one, like 100 dot 200 dot 200 0, and the same subnet mask /30, and we'll give .1 here and .2 to there. Okay, since it's going to be easy. Right. This is okay. Right. Let's configure. Let's move to here. Okay. Now let's configure our FA01. So I'm going to say interface A0/1. Then I'm going to say this is not a switch port anymore. This is a switch, but this port FA01 is not a switch port anymore. So I'm going to say no switch port, because now it is capable of routing, right? Then I'm going to give the IP address 100, 200, 100, 1, and the subnet mask is going to be 255, 255, 255. Since it's 30, it's going to be 255 minus 3 is going to be 252, right? And I'll say no. Let's go to our the end and do the same thing. IP routing, we executed that command. So then interface FA0/1. Then no switch port again, because it is a layer 3 switch. So we have to disable it. And IP address, in this case, it's going to be 100, 200, 200, 1. Same subnet mask, so it's going to be 252. And I'll execute the motion test. Okay. Then let's configure our router, since our links are still down, because we have to configure it from this side. So be going here, CLI, enable, I have to give a name for this one as well. I'll give the name as hostname CR01. And I'll configure the interfaces. So interface gig, I don't have to run the command no switch port here, because this is a router. So 000 in this case. And the IP address is going to be 100, 200, 100. In this case, you can see here it should be. And then say the subnet mask 255, 2. And now shut again. Right? You can see now it's up. Hit from here, interface, gig 0/0/1, IP ADDR 192.168. Good. That's my muscle memory typing 192 addresses. It should be 100, 200. In this case, it is 200, and it will be, and then submit mask. Right. And then I'll say no shot as well. You should see a green light in WordPress. Might as well configure the WAN interface. That means our serial interface as well. We have to give an IP for that. Let's use something like to this network, something easy, 101 10.0/ again 30, and then this will become the .1, and this will become the .2. Right? Let's do that like that. So I'm going to go here. Exit from this interface, I'm going to go to my interface serial. So interface SC0/1/0. Okay. Then I'll give the IP address 101.10.10.1 subnet mask. Okay. Then I'll issue the command no shut. Go to this side. I'll finish up my interface work. For this router, I'll give the name as internet. So right. And then I'll give the IP address interface SC0/1/0 IP ADDR 101.10.10.2 and same subnet. And don't forget to run the command motion. Other than this, so since this is the internet, I'll configure a loopback IP for 8.8.8.8. So I'll make the loopback for 8.8.8.8 since it is the internet. So I'll run the command interface. First, I have to exit from here. Then I'll run interface loopback 1. You get a small prompt saying it's up now. Then I'll give the IP address 8.8.8.8 255.255.255.255. And it's the loopback. Right. Now we have our loopback. So I'm going to exit from here. Show IP brief. Sorry, show IP interface brief, right? Interface brief, and I can see my loopback IP, which is manually up. Okay, we are done up to some level. So in our main network, now let's forget about this one. Our core switch, this core switch doesn't know about VLAN 10, 20, and 30. So if you go here, if you run show IP route or something, show IP route, you can see we don't have our 192 network. See, 192.168.10.1 or 10.0, 20.0, 30.0. We can't see anything here, right? So that means now we have to enable routing. Routing tables will update with this VLAN. So it should be 10.0, 20.0, and 30.0. So let's do those configurations as well. So that means we have to select some sort of a routing algorithm. Either you have to go statically, since we are learning more advanced topics. I'll go with the dynamic routing algorithm, and let's go with something like OSPF, right? So let's configure OSPF to share our routing information. Okay, so I'm going to move to MS01, and that means my multi-layer switch 1, and from there onwards, I'll be doing my dynamic routing. Okay, so first of all, let's say router OSPF ID 1, then I will be saying network 100.200.100.1. So what I'm doing is I'm going to enable OSPF in my interface. So that means this interface. So that's why I gave this interface. Then I'll give the subnet mask as 255.255.255.255. Or simply, I'm going to say 0.0.0.0, right? And the area is going to be 0. Then I'll be doing the same thing for the other network. So network 192.168.0, then the wildcard is going to be 255, right? And same as it is area 0. So make sure to type the commands correctly, otherwise it's going to be nightmare to troubleshoot this. So I'll be extra careful when I'm doing this now. So this one should be 20, and this one should be 30. Okay. Now I'm going to exit from here, and I'm going to run the command. So IP OSPF brief. So Should be OSPF interface brief, right? Yes. Now I can see it's in wait, but I do have my OSPF, right? Do have my OSPF. So I'll be doing the same configuration in the core router. Now I'm going to my core router and I'm going to configure my core router with OSPF. So I'm going to move back here. Conf router OSPF1 network. So in this case, you can assume it's the IP I'm going to give, the interface of this IP address of this interface, and it's going to be 0, 0, 0, 0 and area 0. Okay. So 100.200.100.1 area 0. Right. So I'm going to exit from here, exit from here. So let's give some time and then let's run the command show IP OSPF interface brief. Still, yes, now it's working, right? I do get this too. No, it still didn't get 1, 2, wait. Okay. The state is wait, we'll see. Let's configure the other end as well. So in here, usually it takes some time to get the yes, this side is state is DR now. You saw it was before it was wait. Now it changed to DR. So same story, we'll have to give some time. At the meantime, let's configure the other end. That means our standby router. So let's exit from here. So I'm in the configuration mode. Same command. So router OSPF1. Then I'm going to say network 100 or 200, 201, I think. Let me check. Yes. And the subnet mask is going to be as usual 0000. Now the subnet mask. So then for the others, I'm going to say 192, 168, 10.0 with the wildcard 255, which is going to be area 0. Then I'll be reusing that command. Then I'm going to change 10 to 20. Value to 30. Now you can see the neighbor instances are loading. And the 30. Right. If you run exit to IP OSPF neighbor, you can see now you can see the neighbors. This is very important. Okay. So the neighbor ID is 30.1 and then the address is 10.1. This is 30.1, 20.1, 30.1, 30.1. So what's happening here is this, I ran this command in this side. And whatever the neighbors that I'm seeing is the neighbors from this side. Means my MS1 is now visible to MS02. And you can see the neighbor ID is 30.1, 30.1, 30.1. The reason is when we are selecting ID in OSPF, we select the largest IP address. So out of these 3 IP addresses, 10.1, 20.1, 30.1, largest value is 30.1. So because of that, the neighbor ID is 30.1. And let's run the same command in this side. Show IP OSPF neighbors. Now you can see 3 neighbors. In here, it is 30.2 because in this side, the VLAN IPs are 10.2, 20.2, 30.2. The largest number is 30. So the 30 is taken here. And you can see the other neighbors as well. And now if you go to this router and run the command, show IPOF if interface brief and show IP OSPF neighbors, you still can't see anything, right? You can see that. Or if you run the show IP route, now still you can't see any OSPF routes. What could be the reason for that? Okay, so I'm going to go back to my CR01 here. Then I'll execute my command IP OSPF 1 area 0. I have to go inside interface. So I have to go to my this interface now, which is going to be the gig. So interface gigabit Ethernet 0/0/1. That means this interface, because as you saw, we configured to this side. We didn't configure it to this side, right? So we have to configure to this side as well. 0/0/1, right? And then we are going to say IP OSPF 1 area 0, right? Now we have to give some time and let's see whether we'll have to troubleshoot anything. Okay, we got the neighbor adjacencies. You can see everything got updated. Now let's run show IP OSPF neighbor. Yes, now we can see 100, 200, 201, which is a little bit okay. But I was expecting 2 neighbors actually. Okay, that means I was expecting neighbors as this one, so I get it 201, and I was expecting neighbor from this side as well, right? Probably my configuration went bad somewhere, so let's run a show run and see whether I've configured my gig 000. The gigabit Ethernet 000 is configured with the IP. Okay. Yes, for route OSPF, it was only configured for this. You can see. Let's configure the other end as well. So I'm going to exit from here. I'm going to run the command conf t interface gig 0/0/0 router OSPF 1. Right. Area 0, right? Area not route, it should be IP OSPF 1. Area 0. Okay. Again, I'm getting an error. Exit. I'm going back again. Conf t interface gig 0/0/0, which is this interface. And I'm going to say IP OSPF 1 area 0. Okay, ran the command. Let's give it some time. I'm going to exit from here. From here, show IP OSPF neighbor. Still, I'm not getting 2. That's the problem, because I was expecting to see all my neighbors. That means both neighbors here. But for some reason, I'm not getting it. Right. So let's check show IP route here. Correct. Everything works. No. You can see we only get 1 route. It should be 2. Right. For some reason, we are not getting it. So we'll have to double check whether we have done anything wrong in the previous commands. Probably I might have. Otherwise, it should work now. So it's okay. We have configured it. Here it's 100.100.100.1. Is it correct? 100.100.100.1. Is it 100? I think no. It should be, let me see. Let's go to our diagram. I think I found the problem. Yes, I found the problem. So in here, I figured my problem. So when I was configuring my route OSPF1, I gave the IP address as 100.100.100.1. It should be 100.200.100.1, right? So I have to redo this. So I have to go to route OSPF1 and again get this command. I'm going to conf t router OSPF1. Then I'll again take this command and I'll type no in front of it, right? So I'm going to copy and paste it. And in here, I'll say no. If you're doing this, and you're doing it for the first time, make sure to type it correctly. Then you'll get the expected output. In my case, this is the problem that I faced. So 201, and now I should be good. Right. So this might take some time to make it work. Actually, the problem was actually there, so you don't have to run anything else. That was the only problem. So I'll not get it for now. Did I? Yes, now I'm getting the new adjacencies. It's loading. So the next time I run it, I see two paths, the same destination. So I'll run the command again. Nice. Now you can see the difference. So now I have two paths. Either I can go to the network from, let me show you, from here or here. But now you can see is a problem, right? Because we are running HSRP, right? When we are running HSRP, we don't need to see this. So you can see here, if you run show IP route, you can see the other end as well, the other VLAN as well, this one, OSPF. So you can see it is connected, this one. But this is on standby, so this one doesn't have to see this one. So we have to make sure this is not a bug. Now we have to configure it in a way where it's not going to get details about this VLAN. So we have to configure these as passive interfaces. That's it. We have to do a small configuration. So now what I'm going to do is, since we can see both DS01 and DS02, but we don't need to see both DS01 and DS02. That means, sorry, MS01 and MS02. What I'm going to do is, I'm going to configure passive interfaces for VLAN 10, VLAN 20, and VLAN 30. You now do a small Google. What is a passive interface? I think I explained what is a passive interface in OSPF, right? Basically, there's not going to be any neighbors for passive interface. So I'll be moving back to my MS01, right? And I'll be configuring passive interfaces for this. So I'm going to say router OSPF1. Then I'll say, so I'm going to go to configure terminal. So conf t, then router OSPF1, right? And then passive interface, VLAN, exit from there. You'll get a prompt, exit from there. Then I'm going to do the same thing. Route OSPF1, passive interface, VLAN 20, right? And then passive interface, VLAN. So I ran 3 commands in this side. I have to do the same thing in the other side as well. I'm going to go back here. Remember this out. So I'm going to go here. I'm going to execute the command router conf t router OSPF1, right? And then passive interface VLAN 10, passive interface VLAN 20, and passive interface VLAN 30. Right. Now we have done it. Now let's go back to our MS02, exit from here, Now just run the command. So IP OSPF neighbors, and now you can see only this. Means you can only see the router. That's how it should be. And if you run the show IP route, again, you'll not see the other VLANs because now it is directly connected to the router. You are not going to see this one. That's how it should be, right? And if you go here, the previous case you had multiple paths. Now let's run the same command. Now you can see it's better here as well. And let's go to this side and see whether we have fixed the problem. Exit, and show IP OSPF neighbor. You can only see the router now. And if you run the command show IP route, again, you'll only see the route that is directly connected to you, right? That's what we want here. And only OSPF connection you are going to see is the core router itself. But in the previous case, I think, remember, we saw other end as well. That means sides VLANs as well. So now it's done, right? Now it's done. So let's move back to here. Let's explain what's happening here. So to run the command, show IP OSPF neighbor, you can see the neighbor ID, right? So the neighbor ID is 101.10.10.1. The reason is that is the highest IP address. So the highest IP address will be taken as the router ID. Okay. Now we are done to some level, right? Now let's configure NAT, because now we want to access 8.8.8. So first of all, let's check whether we have routing between the VLANs. So 192.168.20.1, because it's, yeah, we have access now because now the routing is working perfectly. So if we go to 30.2 or something, let's see. Okay, in some time. Okay, request timeout for the first one. Okay, now we are getting a reply. So the connection within here, the connection within our network is now done, right? So that part is done. Now we have to configure NAT. So the NAT configuration will do it in the part 3. So I'll see you guys in the